in our webinars, and 90% of them company owners and decision makers, and the other 10% are on their best way to become company owners, thought leaders, decision makers, all of them. But if you see the UTech Chamber as a whole, there's much more we have on offer. We give an access to speakers and panelists, because the people who are there are meant to be there for networking. There are business opportunities you can find with us, and there are EU projects and fundings we can give you access to if you are a member of the UTech Chamber. But there are many more things to mention, but let me first get back to my IT colleague. Okay, I've seen in the chat that there were sound problems mentioned. Thank you for mentioning them. And thank you for your feedback about the sound problems, Dr. EKT. If there's something, I am glad that my dear IT colleague is here to help. So please do not hesitate. Yeah, do not hesitate to utter your problems. We are here to help you. We are here to give you the best experience possible, and we are here to share knowledge. And it's good to see that you can hear the shared knowledge. So thank you very much for your help in the chat. I was talking about the EU Tech ecosystem. We offer insights, we offer certain programs, and we offer the tech.forum. The tech.forum is our event webpage where you register, but it offers much more. It offers virtual booths, virtual expos, matchmaking tools. So please go trying. And we offer programs like social media support for your company, awards, a climate action partnership. We've just finished our yearly position papers, where we gather the opinion of different advocates of our IoT Alliance. We publish a quarterly magazine called Visions for Europe. Please also subscribe to our newsletters, and please also feel free to utter your opinion when it comes to our white papers. So all in all, as I said, we're here to network. Please network with us. Try our matchmaking tool on tech.forum, or write us an old school email using info@utech.org. Thank you very much for your attention. And now it's on me. It's a real big pleasure to introduce our keynote speaker today. I'm happy that Manuel Schweiger, right from beautiful Vienna, second district, has found the time and is going to give his presentation. Manuel, before I give you the presenter's rights, let me just lose a few words so that our audience can learn more about you. Manuel told me that he's a senior software developer and a robotics engineer at Smart Inspection company, and he sent me this to read it out, because this I found it great to see that this is how he would describe himself. I quote Manuel. He said, "I feel comfortable between both hardware and software, as the interdisciplinarity of robotics is my passion. Therefore, increasing efficiency and safety by deploying robotic solution is my goal. Further, I'm curious about innovations and thinking about how to improve outdated processes while keeping in mind about sustainability. I'm passionate about astronomy, physics, software development at both embedded level and machine learning applications." Dear audience, this is, I think we are gonna learn a lot from Manuel right now. Manuel, I have given you the presenters, right? Please go ahead, the floor is yours.
Thanks for a nice introduction, Joyce. That was a great welcome. Welcome, audience. Thanks for joining in. My name is Manuel Schweiger. As Joyce already said, I'm a robotics engineer or software developer or robotics expert. Call it whatever you want. At Smart Inspection, a company within Wiener Stadtwerke, so it's a quite big company within the city of Vienna. And my today's presentation is about general smart production with IoT, but more in detail about robotics, how robots can improve processes in big industries, in production lines, in power plants. Let me start with explaining the challenges and goals we are addressing with our solutions and products. In general, we had to think about future. Beside the tremendous energy crisis we are currently facing, which everyone knows, we will have to face a tremendous shift in demographic changes distributed all over the world. As a result, many job positions cannot be filled anymore due to the high amount of retirements of the baby boomer generation. That's why a lot of knowledge from long-time employees is about to be getting lost. That's why our ultimate goal is to adopt agile mobile robots in productive plants to make operations safe, efficient, and predictable. With that, we are capable of automating repetitive tasks, increase staff safety, improving safety and availability of the plant itself, collecting consistent data, and we are also trying to digitize employee knowledge. This means when you have employees which are already more than 20 years in your plant, they have a lot of knowledge of your plant. They know when there is a crackling sound somewhere, they exactly know, okay, this is this pump and this is this machine. And all that knowledge of those employees, long-time employees, which are going to retire in the next 5 years, is about to be getting lost. And we are now trying to catch that up and to at least collect all that knowledge before those employees are about to leave the companies. Let me next talk about the challenges we are facing. In general, facilities need to collect data and perform hazardous or remote inspections in environments built for humans. This is our first challenge. So all the plants, all the factories are built for human. And now we are trying to integrate or to adopt robots to collaborate with the human workforce. So this is our biggest challenge. And that's why we need to think about the building infrastructure. How can the robots operate there? Are there stairs? Are there some kind of hazardous places where the robot can fall into, for example? What about network infrastructure? Big companies, facilities, factories, is there Wi-Fi coverage? Do you have cellular coverage? All that stuff. Next important point is IT security. We are collecting a lot of data, a lot of images, a lot of sensitive data about the production line, for example. What about privacy? Is there, for example, a face on some images from human? Then we have to think about all the privacy stuff and data governance. Next important points are data transmission. How can we transmit all the data we collected before with our robots? This is a huge amount of data. Imagine a robot is doing some kind of work over 2 hours. Then there are already some gigabytes of data collected, which needs to be transmitted somewhere. And last but not least, it's very important to integrate robots into the workflow. It's not good if you use your robots and then you place it into the workflow without taking the employees from beginning with you. So there's a lot of communication to be done. You have to talk to the employees. You have to tell them how to use a robot as a tool. And you also have to think about when adopting robots that long-time employees, their first impression is this robot is gonna substitute me. This is always the first impression, but this is not true because we are helping and collaborating with the workforce so that they can focus on more important and more creative tasks. Hourly inspection rounds where an employee has to check analog gauges and the fill level of an oil gauge, for example. This can be automated so that the employee can focus on repairing some motor or some pump, for example. So those are in common our biggest challenges we are facing when doing such work. How does autonomous robots in productive plants even work? When we see some videos on YouTube, for example, when Boston Dynamics or some other robot suppliers are showing cool videos, you often see the robots in laboratories. This means those are all lab setups. We started from the beginning to use the robot in productive plants. This means the production line is currently running, the power plant is currently producing electricity for the whole city of Vienna, for example. And that's why we had to think about a useful setup. To mention before, there is no out-of-the-box tool which is capable of doing everything. For now, every project, every robot is a bit of customized because every customer, every facility has its own requirements. But we were able to put it down to three important points. The first point is the data collection. With that, we collect RGB images, we do gas sensing, we do environmental parameters such as temperature, humidity. We are also capable of recording audio or doing thermal inspection. For this, we need specific sensors, which are then integrated onto the robot. So the robot is a carrier platform. The next point is the data handling. As I mentioned before, we have to think about all the data handling and transmission processes. So that's why we are collecting the data first, then we store it somewhere offline on the robot, for example, if there is no transmission channel available. And if a channel is available, we will upload the storage to some cloud or on-premises servers if the customer rather has this data on his own machine and not outsourced to the cloud. But in this example, we started with Microsoft Azure, for example. We upload the data there, and we can also do there the data processing. The different to some other IoT use cases is the edge processing. This is something we can do also. So there are the two ways we can go. We can go the one way, which is process all the data on the cloud. This means we have to upload all the data to the cloud, which leads to a lot of data transmission. The other way around is to process the data on the robot itself. And then only transmit the results to some kind of backend, which is the last step, the output. It's no good idea to collect a lot of data and to process it and then to show a lot of results in some kind of CSV files, Excel files, or whatever. We need to filter all those data, all those plant monitoring, and all this up-to-date and historic data needs to be filtered and visualized to the end user. And the end user is the process engineer, the reliability engineer, or the shift worker. And this means we as technicians, we like to see as much as possible on one view, but our customers, they want to see only the most important information to not get confused actually about the stuff we are delivering to them. So this is the setup. What is the outcome of our products? We use Spot, for example, as a legged robot, which we fully integrate into the plant workflow. With that, we can do autonomous inspection missions, we can read analog gauges, we can read rotometers, we can do thermal inspections. We can do audio analysis, which is still in progress because needs a lot of more time. We can show live streams via secured networks, as I mentioned before, the IT security stuff. And we also can use the robot as a remote control carrier platform. This means we have developed a solution, a product, where you can use it in two important points. And the one is everywhere you do not want to send employees there. For example, it's a too dangerous environment. And that's where you can collaborate with human. A human workforce is controlling this robot in a dangerous environment. For example, imagine fire brigade, for example. You don't want, even as a fire brigade worker, you don't want to get into the recently burned building, for example, because it's about to fall down. Then the worker just uses a controller and sends the robot in there and checks if this is dangerous to walk in there. And the other way around, or the other use case is everything what is repeatable. You can use robots to help and support the human workforce. And that's what we made actually. Our first customer, or our biggest customer, is Wien Energie, one of the largest, or actually the largest energy provider in Austria. They operate a lot of power plants, and there we deployed this robot. I will show a video later. But what can they do over there? The robot in action provides to the process engineers or to the shift workers, for example, the possibilities to analyze, for example, gauges or pumps or valves or those pipelines, as you can see on the image. They can draw a certain region of interest around this pipeline, for example, and then the data or the temperature of this pipeline is analyzed. If the threshold, which was set before by the process engineer, for example, exceeds a certain amount, an alarm will be generated. And this means you can do every day's inspection completely automated. And then the process engineers is just looking to the output of the thermal analysis anymore. Next one is, as I mentioned before, the remote control option. You have here a controller, for example, which allows you to control the robot completely remote via some secured channels. This might be also cellular networks, for example. Next one is the audio analysis. At the moment, we are doing Fourier transformation and having a look at the frequency domain of the audio to get patterns of defect bearings, for example, or a pattern of a defect motor. And that's what we are currently trying to accomplish. One of the most used use cases, actually, I didn't imagine, but this is one of the most important use cases, is reading analog gauges, because power plants, or actually all kind of plants, are built for 30 to 60 years. So they are building to be used a very long time, and this means you see a lot of analog gauges in plants because they are not digitized yet. So employees are walking around the plant to have a look at those gauges, and then they write it down on some kind of sheet, and then they bring it to the next station, and maybe then it's written into some Excel sheet, for example. And this is boring, uncreative work, which we are automating. So this is also collaborating, actually. So we are trying to support the employees that they can do the more important tasks. And
sorry, Manuel, to interrupt you, but I have to have a bit of a close watch on the time. So sorry, if I got to be strict there. I could continue listening to you for hours, but yeah.
This was actually my last slide, so
okay.
I'm finishing up with a nice video, because videos show you more than a 1 hour presentation. This is the robot dog spot, which we deployed at Wien Energie, Kraftwerk Simmering in Vienna. And just have a look at it. I will start the video. So
We're
let
live
me
on, as they say in Vienna.
let me get
This is
back to the presentation.
this is amazing, Volker. You're gonna be stepping in big footsteps, I'd say.
So this is actually the video which is showing everything we are doing currently, and one of the most one of the things I'm very proud is that they see this tool as a colleague, and this means we successfully integrated or adopted this robot into their workflow. And this means actually we can do all this visual inspection together with them. I will keep it short. We have some other projects as walking through tunnels, for example, where we don't want to walk through as a human. And that it actually. So thank you for your time. I'm sorry for exceeding the time a bit. And I'm looking forward to your questions.
That was really, really amazing. Thank you very much. We have a Q&A session right after the panel discussion in a few minutes. So I'd like to switch to Volker. Volker Kunze is a board member of the Sustainable Manufacturing Alliance. Volker Kunze is a technology scout and expansion manager at the Additive Minds Academy. He's a tech learning enthusiast, and I'm gonna hand over. Yeah, he has presentation rights right now. Well, my first question to you is, Volker, have you ever been a tech learning enthusiast?
Yes, it varies over time. Yes, so I must say it started with my father. Yes, he have been the first one having a programmable calculator, the TI-30 in the early 70s.
Oh,
Yes, so I and I was loving all these technical gadgets that were coming up over time. Yes, starting with the video game Pong. Yes, in my youth, and so over time, and then it came more and more into the area of using it for my job role. Yes, and if you have a look today, yes, the chances we have with Web 2.0, with all the video meetings, yes, and with during COVID, using distance training, due extended reality, having smart glasses from VR to AR. Yes, and now you have artificial intelligence, and the metaverse is around the corner.
and what do you in particular think about these robots Manuel has just presented? What role do they play in your learning vision?
I will show it a little bit here, and I present the video, and to give you some little background. So this is a vision of a smart factory which we started maybe 5 years ago. Yes, and you see a machine hall. Everything is connected. Yes, you have. We don't have the dogs running around. Yes, but we have
Not
AGVs.
yet, not yet.
Yes, but the AGVs, the transportation system, you see the red ones, they are bringing the build jobs from the 3D printer to post processing. Here you see it. Yes, and so everything is connected to each other. You always know what is produced at what time. And the human factor here is that someone have to repair something, someone have to exchange the filters, have to control the products. Yes, so even during production or even to control, yes, while you're on the way, it's not a good idea to have the handy in your hands while you're driving. But yes, and here you see the part which is finally created, yes, and you have to control how to create your parts with the inner structures. Did everything run well? So this have been the vision, yes, and this is today's view, yes. So today we optimize our production with having a view to the job that is created currently. Yes, so we can see if the laser is working, if the machine is fine, which product. Here you see the product again. Yes, the flow nozzle. And you get the information all the time about your production and what is produced, whether is a failure. And within the machine hall, and this is now a midterm vision, you enter the machine hall and you are quite an expert, but not for every machine. Yes, so you're getting familiar first with the environment, and with the smart glasses, the machine is automatically recognized, and you can train your workforce. So you must not be an extremely expert for everything, but you get an additional information. And then it comes to the point that you use the IoT information. Yes, so like here, for example, we have the CAD job. So here you see the parts that are printed in 3D. Yes, and we do it in metal and polymer. And now you can see directly through the part and the different layers how it is arranged. And now you have the build job. And here is, for example, the installation of one of our machines. Yes, so we have artificial intelligence recognizing the machine and the environment. So here you have to take the clamps off. Yes, and now your next step is to use the heater. And this is a first person view through the smart glasses. Yes, so the installation of our easiest machine. You see our 3D printers are a little bit larger than the normal ones you have seen. Yes, and so you can train your workforce, and even you have quality assurance. So next step will be to add vital data from the machine and even do the machine steering. Yeah, today you see we have a monitor on our machines, but in the future you can have all the information in your smart glasses and use this information to steer the machine, and you even have predictive and preventive maintenance. So the future, yes, and here in the back you see a little cobot, yes, inserting new material cartridge to the machine. But here you see we don't have any monitor anymore. Yes, we have the visual information over here. And even the workplace for the CAD designer will change. Yeah, so you will have your digital environment, and like we have seen, everything is connected. We get all the gorgas, we get all the information that is needed, and we can interact with people overall in the world. So here you see the example with the open glass. The colleague could be in China, he could be in North America, handing over a CAD file to me, and I say, okay, this one looks good, yes, but I want to change something. Yes, and make my annotations to it, and then I'm handling it over back to him. Yeah, so this makes interactive work easily, and same is for ISO and ASTM qualification jobs. Yes, first you get trained in virtual environments, and then you have the instructor testing your knowledge. Yes, and following the rules of the certification. And here you hear people talking, yeah, you see here the avatars, only half people, it looks like a comic. But if you know about where the future is going to, yes, and you will have your own digital twin, yes, digital twin of my own, having no bad hair day, yes, and even taking my emotions, yes. So you see what could be done and what could be ported, and with a new series of VR and AR glasses, all the emotions will be shown, and you see here the digital twin how it will appear in the future. Yes, and so on steroids. Right now, the bot is coming with ChatGPT, and I asked the bot, okay, how to change a filter on an industrial 3D printer, and here the answer is coming in. Yes, so if you train this bot in the background, it can tell you directly what you have to do on your job. It connects automatically. We have seen here the first person view, how to install something and give you the right information for training in the moment of need. So this is really going on steroids right now, yes, and with all the capabilities. So until I retire, there will be a lot of interesting things coming up.
I'm sure there will. I mean, this is definitely on steroids. You're absolutely right. But please, before your retirement, answer a last question to me. When will you call Mark Zuckerberg in order to speed up his metaverse project for your learning vision, Volker?
Good question. So I think he well, I wait to call him that he is calling me. Yes, maybe I could give him some tips about use cases and talking to the public with high quality examples that really solve real world problems. Yes, and in general today. In today's time, people still complain on what is not working and but not focusing on the positive use cases. And same is in metaverse, yes, but same is for ChatGPT. Yes, and if you see what is possible today, and if you know what GPT-4 will bring you, then you can think about what benefits we can have. Yes, so but and not complaining directly about everything and saying, okay, this is not working. Yes, only concentrating on the 2% which are not running well, but really taking what it could do for us.
You are absolutely right. We've all gone a long way, so it's time for positivity as well. Ulf Seimer has another really interesting insight for us. Ulf, I'd like to, for those who do not know you yet, I'd like to introduce you. Ulf is an IoT Alliance board member. He is a devoted member of the IoT Alliance, very active. He's from Sweden, Chief Innovation Officer at Induo. Please subscribe to his blog on LinkedIn. And Ulf is above all a renowned and very experienced 5G and IoT expert. And now he's going to take us to the Swedish woods. Ulf, the floor is yours.
Thank you, Joyce. Thank you, Joyce. So happy to be here. As Joyce said, my name is Ulf, and I work for a company called Induo. And Induo, well, we're a company specialized in IoT devices. So we are helping customers with IoT devices as a part of a digital transformation journey. So today we're going to talk about how IoT in forestry could be used as smart production. So the thing was that Skogforsk, which is the Swedish Forestry Research Institute of Sweden, they wanted to know if IoT could improve work environment in forestry. So it's quite a different environment for IoT. They wanted to know if harvesting the forest could be improved by using IoT to some extent. And when you're harvesting the forest, for those of you who don't know, this was the first time for me as well to understand the concept. So first there is a harvester logging the trees, which is basically like the modern version of the chainsaw. The woods are chopped down, they're put on the ground, and there comes a forwarder that picks up the logs and drive it to a nearby road. And from there on, the logs are picked up by a third vehicle, a timber truck. So Skogforsk wanted to focus on the forwarders because working as a forwarder is a very, very tough job. It's super hard on the body because the vehicles are driving in rough terrain. And normally you don't work your whole work life in a harvester or in a forwarder because it's just too heavy on the body. It's also very lonely work. You work in the middle of the forest in the night, and there's no one to help you if something goes wrong. So the machines are very expensive because you have to protect the drivers and sort of make the best of the situation and don't injure people if it's possible to build the machines to avoid that. As it is a very hard job, it's hard to attract new generation of workers. People don't want to work in this kind of environment. So the research institute, they wanted to understand if they could use the potential of IoT. We saw in the introduction video Joyce showed the self-driving cars, which is a concept of the future. So they wanted to know if they could remotely operate those machines. Could they put more drivers in one place and remotely control these vehicles so that more drivers could work together and even control more of the vehicles using just a small workforce? At the same time, the cost of protecting these drivers that are sitting in the machine, it increases the cost for the machinery. So if they could take the driver out of the cab, they could probably reduce the cost of a machine by 30 to 40%. And at the same time, you would be moving the driver to basically an office job, right? And there are not many hard injuries sitting behind a desk and a computer. And this would also mean that it would be a completely new work role. It wouldn't be that hard to attract a new generation. So they wanted to elaborate if 5G would be a possible solution. As you know, 5G is and remote controlled cars, it's in the same concept. The problem is though that finding 5G in the forests of Sweden is super hard. There are no base stations around. So what they had to do was to build a 5G network at the test site. So they built a private 5G network, which is not the same as a public 5G network. They're running their own infrastructure to control these vehicles. So on the left-hand side, you see a blue cabin. That's where the driver is sitting. And you see an antenna, which is a base station for the 5G network. And on the right side, you see the machine they're actually driving. So this is what it looks like. You have a possibility to remotely control this vehicle using joysticks. And I'm just going to share a video with you because it says more than me talking. So just hang on a second and I'll share video with you.
Thank you, Ulf. That's awesome.
Thank you. Yeah, so I won't show you any my last slides because I see that we're sort of running out of time. So with regards to the next person in line, I'll stop my presentation there. But the bottom line is that I'm sure that in the future, IoT and smart production can really improve both the cost aspect of doing hard work and also help to get work life more healthy. That would be all. Thank you very much.
Thank you so much, Ulf. Birge is the next one in line Ulf is referring to, and Birge is a wood industry expert as well. to be particular, he is an expert in digitalization at the Wood K Plus Competence Center in Austria, and has worked in particular on assistance systems in production. Wood K Plus is part of the Austrian Digital Innovation Hub, Innovate, and the eponymous European Digital Innovation Hub, one of the few hubs that specifically addresses the need for industries, and especially the need for industries, and as I have learned, for small and medium enterprises as well. Innovate aims to support the said small and medium enterprises on their way to digitalization. And I mean, we are lucky to have you here on the panel, Birger. Thank you very much for coming. What do you think about Ulf's business case? Would you like to implement it on the Austrian woods as well?
Yes, of course. I think it is a very interesting business case. And I thought for a long time that teleoperation will be the first step to full automation, because basically we have all the technology there. We know how the machine operates, we have all the signals. So in the future, we can maybe step it even up and make them fully automated. But we know the technology, especially in critical applications, is not there yet. But I think it's the first step, and it can help with many other problems. For example, in Austria, it's kind of difficult to find young people that are willing to work in remote forests, because they want to live in big cities with more other people. And it would be possible for them to work just from their home office, basically, and operate these machines in remote forests. But I have a question, because we also have the problem here in Austria with the network coverage. How difficult is it to set up a private 5G network, and how big of an area can you cover with maybe one cell tower?
So in Sweden, we use a special frequency band for the private 5G networks, which is around 3.5 gigahertz. And that band isn't that good at penetrating the forest with the signals. So you need to put your base station up high, but you can reach up to 1 or 2 kilometers, I would say, using a small base station. If you have a larger base station, you can reach further. But also we are elaborating on using other technologies together with 5G to have the control signals being running on using another technology, basically, so they can reach tens of kilometers, and the video will be the one that will die first if you travel too long from the base station.
Okay. John has handed in a very interesting question on the chat, which matches perfectly here. He asks, and I'd like to pass on this question to Birger and Ulf, what are the likely problems one can encounter in operating these machines remotely? I mean, Birger, you have mentioned the home office willingness from young people.
Yeah, I think it's a very safety critical operation, because they're very strong and heavy machines. And if the network connection would die, it's very important that the machine stops all operation and not just do some random movements, for example. And it needs to be assured that no one can hack it. And also, for example, if you need to do some maintenance on the machine, someone has to be, of course, there. Or maybe we could in future use some robotic quadruped dogs. That would be very nice to have.
For predictive maintenance, yes. Your work focuses mainly on small and medium enterprises. We do not have kind of a forest industry in the Alpine region, just as other countries have. Where do you, as talking about small and medium enterprises, where do you see the potential for cobots in the wood processing industry?
I think there is quite a huge potential, especially to start for small and medium enterprises, to get their hands into robotics with the cobots, because the sensors that are used within those robots make them more safe, and the software is more easily usable now for people that maybe don't have a degree in robotics or mechanical engineering to get into it. And as we heard before, it's very important to get all the users on board on such projects. And it's important to tell them, like, here is a now tool that will help you in your work, and it's not some big complicated machine that's going to replace you. And right now we have the situation that we have many jobs that are not being filled because they are just not the people for it. So the fear of getting replaced is right now not so high as it was only a few years ago. So I think there is right now a tremendous potential to use small industrial robots, for example, also in retrofitting of small workshops, because I can use those robots without safety fences. So I can get closer into connections with the robots and closer into interaction with the robots. And that saves a lot of space.
Yeah, definitely agree. Manuel, we had been talking about generation issues during your presentation as well. So I'd like to pass on the next question to you. What effects do collaborative robots have on the further employment of people in production? Do we need, I mean, in my imagination as a non-expert, I think there's lots of training to be done and lot of updating of production sites. I mean, you've mentioned all the analog settings there and how long they've been staying there in the production sites.
Well, in my opinion, recent production lines or factories or plants are going to build to be more or not that independent from physically attended workforce. This means they are trying to build such, as we heard before, smart factories, one-man plants, digital twins of factories and all that stuff, so that the facilities are not that dependent from physical workforce anymore. So this is the way it's going to be in a few years, maybe 10, 20, 30. But for now, as long as there are still the old plants which require physically attended workforce, this means we need technologies like robots which do the work until every sensor, every machine is connected by itself. So those robots are the pendant to robotic process automation, actually. So until every machine is connected, we need such robots or human workforce which is doing the work. Yeah.
Volker, the human workforce needs to be trained, I guess. This is your hour, I say.
Yeah, so it is very important that skills and competencies will rise extremely, yes, because you don't have waiting times. You will get the information in the moment of need, like the example I gave in the beginning. Yes, you're entering the machine hall. The system even knows what you know. Yes, you're going to a machine which you never used before, so you automatically get a safety instruction. Yes, and after the safety instruction, you do the filter change. And we have compared a manual installation of one machine and an augmented reality served one. And a student with no technology background, she made this installation in nearly the same time like a service engineer on customer side doing it the first time. And the reviewing service engineer said it have been the most accurate commissioned machine ever. Yes, so benefits are on all sides.
Definitely. Ulf has shared a question in the chat as well while Manuel was presenting. So I'd like to read out the question right now. How long can Spot work in your application before here needs recharging?
Well, actually, Spot has in each of its location a charging system which can be reached automatically by the robot itself. The robot has power up to 90 minutes. Depends actually on what are we carrying. If we are carrying a hair dryer, the power will decrease much faster. But we suggest to use the robot for 1 hour and then go back to charging for 1 hour. So we can use the robot in one day in 24 hours, we can use the robot for 12 hours. This means 1 hour work, 1 hour charging.
Okay, very good. Ulf, that answers your question. Very good. And what is, I mean, we had covered so many issues, but I'd like to get back to the predictive maintenance issue, Manuel, because predictive maintenance is also a field of business that really, will keep us busy in the future. What are the points you would wish they could be improved, especially in the predictive maintenance sector, to make your life easier? What is your best vision?
Yeah, well, our robots are actually, our robots itself are actually, or sensors are actually the base for predictive maintenance. Why? Because you need data for predictive maintenance. You need to build a model or something like that. And I'm glad, or what is currently already happening is the field of automated machine learning. This means that all that hard work before building predictive maintenance models, like data pre-processing, post-processing, building up the data pipelines, all that stuff which is now done by data engineers, data scientists, machine learning engineers, is going to be supported by automated machine learning, and that's what I'm really looking for.
Okay, good to see. And what is your worst case scenario regarding plant safety?
Well, when adopting robots, the worst case scenario is all the time getting a human injured in some way. So accidents are our worst case scenarios, and it's getting worse when human workforce is getting injured, and that's why we are trying when adopting the robots to keep human workforce as safe as possible.
Okay. Birger, what is your worst case scenario, especially for the small, medium enterprises, wood industry?
Yeah, also injury, of course, is the most dangerous, but I think also robots can help in preventing those. For example, if you think of a wood shop operating dangerous sawing machines, that could be done by a robot, so that would help. And the other thing is, of course, if people are not exactly sure how to use the robot, they get it and try it, think the robot will do everything for them, and then they will be disappointed. So it's kind of also a worst case if you have really high hopes and they are really disappointed because you didn't know how to use it properly.
Very good point, especially when thinking about the target group. How can training prevent this disappointment, Volker? Do we all need to learn a lot more about this kind of technology?
No, the benefit is even that you can unlearn. Yes, you must not keep the knowledge all over time. And if you see the curve of how the technology is rising, yes, so you can unlearn. Like, for example, you change the filter on the machine and then you can forget it, the procedure, because next time you need it, yes, and all these boring tasks you don't have to be done. So the cobots will help us in various reasons. And another thing is sustainability. Yes, like in predictive maintenance, yes, when to change a filter. Today it's a strict cycle. Yes, but in the future, it will be the amount of air going through the filter. Yes, and once it's reached the capability, then the filter have to be changed. So there are so many benefits with the cobots coming into, and I added some of them here in the chat.
Great, thank you. Ulf, although Volker has been talking about unlearning, I'd like you to ask about your key takeaway message of today for our audience. What would you like our audience to keep in mind for today?
I think that the main takeaway is that there are a lot of opportunities ahead. There are a lot of things that IoT can do to change, to do these repetitive tasks to have someone watch your factory 24/7 with a dog, for example, like Spot. So IoT is really an enabler in the. I'm sure that there are tons of use cases where we can use IoT to build a better world in the future.
Let's do so, yeah. Birger, what is your key takeaway message for the audience of today's webinar? What would you like them to keep in mind?